Every year, when the icy waters of the Bering Sea begin to freeze over, a brutal race begins. Alaskan crab fishing isn't just a job. It's one of the most dangerous professions on Earth. With 40-foot waves, sub-zero temperatures, and the ticking clock of a limited harvest window, crews aboard industrial crab boats risk everything to bring home the prized Alaska king crab, known worldwide for its succulent meat and massive legs. But how exactly do they catch hundreds of tons of these ocean giants? And what happens after the crabs are pulled from the deep? Today, we go behind the scenes, from setting 800-pound traps in freezing water to processing the crabs in high-tech coastal facilities. This is the story of modern crab fishing at industrial scale. Stay with us, you'll never look at king crab legs the same way again. Our journey begins in Dutch Harbor, Alaska. The most important port for commercial crab fishing. Here, massive crab boats, some over 150 feet long, are being prepared for the winter harvest. Each boat is loaded with dozens of steel crab pots, each weighing around 700 to 800 pounds. These cages will be used to catch and trap crabs from the ocean floor. The crew inspects everything: hydraulic winches, bait chutes, navigation systems, weather radar, life-saving equipment. They also load several tons of bait, typically chopped herring or squid, used to lure the king crabs into the pots. Once supplies are ready, the captain files a plan with the U.S. Coast Guard, and the vessel heads into the Bering Sea, one of the most unpredictable and treacherous fishing zones in the world. The season lasts only a few weeks, and quotas are tightly regulated by the Alaska Department of Fish and Game. Each licensed boat is given a specific weight quota, sometimes 100,000 pounds or more. With that in mind, every hour on the water counts. Once the vessel reaches the fishing grounds, often hundreds of miles from shore, the real work begins. Using cranes and hydraulic arms, the crew begins setting the crab pots. Each pot is a steel frame cage about 7 feet wide and 3 feet tall, filled with bait, marked with buoys and GPS for tracking. They're dropped one by one into the sea, descending 300 to 700 feet to the ocean floor, where king crabs are known to roam. Crews often drop 50 to 100 pots per string, forming a line that can stretch over several miles. After 24 to 36 hours, known as the soak time, the pots are pulled back to the surface. This is where the magic happens. Crab pots can come up with 30 to 60 full-grown king crabs, weighing over 400 pounds per pot, with massive leg spans over 5 feet across. Not all crabs are kept. Only male crabs over 6.5 inches across the carapace are legal to harvest. The rest, including females, are immediately thrown back into the ocean. This practice ensures sustainability and future populations. Sorting is fast, brutal, and wet, especially with 20-foot waves crashing across the deck. Once sorted, the king crabs are placed into live tanks built into the deck of the boat. These tanks are filled with chilled, aerated seawater, keeping the crabs alive until they return to port. Maintaining the right temperature, between 33 and 36 degrees Fahrenheit 0.5 to 2 gigs, is crucial. Too cold, the crabs go into shock. Too warm, they suffocate. Crab boats are equipped with seawater circulation pumps and oxygen diffusers to keep the crabs healthy during the journey back, which may take 2 to 4 days. Some boats also have blast freezers to snap freeze any crabs that die in transit, ensuring no meat goes to waste. By the time they reach shore, the tanks hold tens of thousands of pounds of live, active king crab, each worth up to $200 in restaurants around the world. But the journey doesn't stop at the dock. Back in Dutch Harbor, the crabs are offloaded directly into processing plants just meters from the docks. Here, every minute counts. Live crabs are delicate and lose quality quickly. Step 1. Inspection and weighing. Each crab batch is logged, checked for quality, and weighed for quota records. Step 2. Stunning and cooking. Crabs are placed into high-pressure steam cookers or boiling vats. They're cooked for 12 to 18 minutes, depending on size, turning bright red in the process. Step 3. Cooling and leg removal. After cooking, the crabs are chilled rapidly in cold seawater tanks to prevent overcooking. Their legs, the most valuable part, are separated by hand or mechanical arm. Step 4. Packaging and freezing. The legs are placed into stainless steel trays and sent to blast freezers at -40 degrees. This process locks in the flavor and texture without preservatives. Step 5. Grading and boxing. Once frozen, the legs are sorted by weight: medium, under 1 pound; large, 1 to 2 pounds; jumbo, 2+ pounds. They're then vacuum sealed, labeled, and boxed for global shipment. From sea to freezer, the entire process can take under 8 hours. The final product is either shipped fresh to restaurants in the US and Japan, or exported frozen to supermarkets around the world. Once processed, the king crab is packed into temperature-controlled containers and sent via air or sea freight to international destinations. Top buyers include high-end restaurants in Tokyo, Seoul, and New York, gourmet grocery stores in Europe, seafood festivals, and cruise lines. To maintain freshness, logistics teams use real-time temperature monitoring, GPS-tracked containers, dry ice or refrigerated gel packs. Some crabs are shipped live in oxygenated tanks for luxury dining experiences, a logistical feat involving custom aircraft compartments and strict timing. In peak season, a single plant can export over 500 tons of king crab in just a few weeks. And all of it starts with a handful of boats braving the icy waters off Alaska. The Alaska king crab industry is strictly regulated to protect the species. The state uses scientific surveys of crab populations, strict harvest quotas, limited entry permits, a legal size and sex restriction system. These efforts have helped prevent overfishing and ensured king crab populations remain healthy for future generations. In recent years, climate change has added new challenges, with warming seas affecting crab migration and survival. To adapt, some companies are investing in data-driven tracking systems, eco-friendly bait alternatives, hybrid electric vessels to reduce emissions. Consumer demand for certified sustainable seafood has also grown, putting pressure on the industry to stay transparent. Thanks to collaboration between scientists, fishermen, and regulators, the king crab industry is becoming a model for sustainable, high-value seafood production. From the depths of the Bering Sea to fine dining tables around the globe, Alaska king crab is more than just seafood. It's a triumph of endurance, engineering, and respect for nature. Every leg you crack open carries with it the legacy of a dangerous journey, a hard-fought harvest, and a system built on sustainability. It's one of the few products where human grit meets modern innovation, and the result is delicious. So next time you savor a bite of king crab, Remember the men and women who made it possible, risking everything to bring the ocean's finest to your plate. Every year, millions of tons of sausages are consumed across the globe. From street vendors in Bangkok to breakfast tables in Berlin, sausages have become a staple in diets around the world. But have you ever stopped to think, how exactly are sausages made? Today, we'll take you on a remarkable journey. From the moment piglets are born on high-tech farms, to the precise science behind spice blending, to the high-speed machinery that produces thousands of sausages every hour. This is the story of how traditional flavors meet industrial innovation. Let's uncover the full-scale operations that turn pigs into one of the world's most beloved foods. Modern sausage production begins far from the factory, in vast, carefully managed pig farms. In today's industrial agriculture, pigs are raised in facilities that can house hundreds of thousands of animals. These farms use cutting-edge technology, automatic feeding systems, environmental controls, and even AI-based health monitoring. Each pig is tracked from birth to ensure optimal growth, weight gain, and well-being. Piglets are nursed by their mothers for the first few weeks, then transition to a scientifically designed diet, including grains, proteins, and vitamins. Health checkups are performed regularly, with real-time data collected on temperature, behavior, and feed intake. Why so much technology? Because the quality of the meat begins here. Healthier pigs produce better meat, and ultimately better sausages. After 5 to 6 months, when pigs reach a weight of around 100 to 120 kilograms, they're ready for the next phase, processing. Once ready, pigs are transported from the farm to the processing facility. But this step isn't simple. Stress in pigs can affect the quality of the meat, so transportation must be calm, quick, and tightly regulated. Upon arrival, pigs are handled humanely, with modern slaughterhouses following strict animal welfare standards. Automation plays a large role here, minimizing human contact and maintaining hygiene. Slaughter takes place in sanitized environments. The carcasses are immediately cleaned, inspected, and cooled. Only the best cuts are selected for sausage making, primarily the shoulder, loin, and rump. These cuts offer the ideal balance of lean meat and fat, crucial for texture and taste. Tendons and excessive fat are removed, and the meat is sent to the sausage production line. Here's where science meets flavor. First, the trimmed meat is ground to a fine texture. The ideal sausage mixture usually contains a calculated ratio of lean meat to fat, often around 70-30. This ensures a juicy, firm sausage that doesn't dry out during cooking. Next comes the spice mix. This is where sausage brands get creative. Common ingredients include salt, pepper, garlic, sugar, nutmeg, coriander, and monosodium glutamate, MSG. But every brand has its own secret blend, some recipes passed down for generations. Some sausages are spicy, some are sweet, others smoky or cheesy. Ingredients like jalapeno, cheese cubes, or even fruit are added depending on regional preferences. Everything is mixed in industrial tumblers that ensure even flavor distribution. The resulting mixture is a fragrant, sticky paste, ready for the next step, stuffing. Once the meat and spice mixture is perfectly blended, it moves to the next critical stage, stuffing and cooking. This process begins with industrial-grade stuffing machines. These automated systems inject the meat paste into sausage casings with high precision, ensuring uniform shape, density, and size across thousands of links. The casings can be natural, derived from the cleaned intestines of animals, or synthetic, like collagen or cellulose, which are preferred in high-volume production for their consistency and shelf stability. The stuffing machines can operate at speeds of up to 12,000 sausages per hour, forming continuous strands that are then mechanically twisted and cut into individual portions. Robotic arms, or conveyors, guide the links to the next stage without human contact. maintaining strict hygiene. Once stuffed, the sausages undergo thermal processing, the phase that transforms raw ingredients into ready-to-eat food. Depending on the sausage variety, the links are either steamed, boiled, baked, or smoked. For example, hot dogs and frankfurters are commonly steamed, while bratwursts and salamis are smoked in large chambers. These chambers are equipped with programmable settings for temperature, humidity, smoke density, and airflow to ensure consistent results. The most important safety measure during cooking is reaching the proper core temperature. Most sausages must reach an internal temperature of at least 71 degrees Celsius, 160 degrees Fahrenheit, to eliminate harmful bacteria like Salmonella or Listeria. To ensure this, factories use inline temperature probes and infrared thermal scanners. These devices continuously monitor the internal temperature of random sausage samples on the line. If any batch fails to reach the required temperature, it's automatically diverted for recooking or disposal, leaving no room for error. In some high-end facilities, real-time sensor networks collect data from multiple cooking zones, adjusting steam pressure or smoke flow on the fly to account for environmental changes. This ensures each sausage is cooked evenly, thoroughly, and safely, regardless of its position on the conveyor. After thermal treatment, the sausages are rapidly cooled in chilled tunnels, giant refrigerated chambers that bring down the temperature within minutes. This sudden cooling locks in flavor, halts bacterial growth, and helps retain the sausage's structure and moisture. Whether it's a breakfast link, a smoky bratwurst, or a cheesy cocktail sausage, every one of them has gone through a tightly controlled process of stuffing, cooking, and chilling that combines precision engineering with food science. Now the sausages are ready for packaging. Most are vacuum sealed in plastic to extend shelf life and prevent contamination. Some are packaged in nitrogen-filled environments to further slow spoilage. Labels are added with expiration dates, nutrition facts, and tracking barcodes. Automated quality control systems scan each package to detect air bubbles, leaks, or visual defects. Any flawed product is automatically removed from the line. From there, the sausages are boxed, loaded onto refrigerated trucks, and sent to supermarkets, restaurants, or ports for export. Mass production allows these sausages to travel across the globe, from Chicago to Seoul. Sausage is more than just food, it's a symbol of regional identity. In Germany, you'll find smoky bratwursts and spicy Thüringers served with mustard and beer. Italy offers dry-cured salami and pepperoni, often sliced thin and eaten cold. Japan has arabiki sausages, small, juicy links with crispy skins, popular at breakfast tables. Each region uses its own techniques, spices, and meat cuts. Pork is most common, but beef, chicken, and even seafood sausages are gaining popularity. Global brands like Johnsonville, USA, CP Foods, Thailand, tailor their recipes to local tastes, creating sausages for every culture. The sausage industry isn't standing still. With increasing demand for healthier and more ethical options, companies are investing in alternative sausages. These include organic sausages, made from pigs raised without antibiotics or hormones; preservative-free sausages, using natural fermentation or vacuum sealing instead of chemicals; plant-based sausages, using soy, wheat protein, pea protein, or even mushrooms. These vegan sausages mimic the texture and flavor of meat, appealing to vegetarians, flexitarians, and environmentally conscious consumers. Technology also plays a key role. AI systems now optimize production, detect contamination, and adjust cooking parameters in real time. Blockchain is used to track each sausage from farm to fork, offering transparency in food origins and safety. Even 3D printed sausages and lab-grown meat are being explored, offering glimpses of a future where food is sustainable, scalable, and customizable. From humble beginnings on a farm to high-speed processing lines, sausage production is a marvel of modern food science. It blends agriculture, technology, culture, and commerce, feeding billions of people while adapting to changing tastes and ethical concerns. What started as a way to preserve meat has now become a $50+ billion global industry. So the next time you bite into a sausage, whether grilled, fried, or boiled, remember the incredible journey it took to get there. A journey made possible by farmers, engineers, food scientists, and centuries of culinary tradition. Thanks for watching. If you enjoyed this deep dive into the world of sausage production, don't forget to like, share, and subscribe for more behind-the-scenes stories on how your food is made.